Hey everybody, this is Dr. Schultz. I hope you are watching this video right now. What I'm going to do is just kind of go through a couple of announcements on our daily agenda for today, and then I'm going to get you started on activity 4, which is the activity that you'll be doing in today's lesson in physics. So let me start with the announcements. I'm going to read up at the top here. We are going to be spending a little bit of time together in the last week or two of school here. Today and Thursday and Friday and Monday, we're going to be doing faulty circuits activities. Next week on Tuesday and Wednesday, you will be taking an individual summative that covers everything in Unit 7, which is on practical circuits. And then Thursday and Friday of next week are going to be the remediation and support days for students who are not passing and who have, shown enough work where they might pass if they come in for that extra day. So you would only be coming in if you got an invitation from me, which I would be contacting you about next week. But again, so we've got a couple of days here this week we're going to be spending on faulty circuits, and then next week we're going to have an individual summative for Unit 7. Okay. If you're wondering what's on the unit summative, it will be things that we have been studying in Unit 7. And I would recommend that you take a look at the circuit notes document that has a lot of good stuff in it. Okay. I'm also likely to ask you to make some wire connections and to test continuity. Yes, that means like actually do those things for me as part of the test. So hopefully you've had enough practice in the last 4 block days of doing that kinds of hands-on stuff, because I'll probably ask you to do something. But definitely review the circuit notes and review the other activities just quickly, okay? All right, so that's pretty much what we have for announcements. Today in the lesson, you are going to be using a circuit diagram to identify the errors in the circuit. That's great. For our activities, all right, first of all, you're watching this video. That's good. I'm gonna get you started on the activity, and then we'll take a look at the activity itself. All right, so at this point, please go ahead and I'd like you to go to Classroom, and I would like you to open up activity 4 on Classroom. It's called something like circuit diagramming practice. It is a CAMI assignment, so you're going to need either a stylus or you're going to have to use your finger for this to make your sketches. But please go ahead and do that right now. It should be under classwork. It's activity 4, and then I will show you how to get started with this. Okay, so you might want to pause the video for a moment until you've had a chance to open up activity 4. Okay, and I'm going to then kind of walk through with you the instructions, and we'll even do the first example together. Okay, so activity 4 should look like this when you open it up in CAMI. There are 3 different parts to activity 4, and we'll do the very first problem in part 1 together. So I'm going to read up at the top where it says part 1. It says below are 4 circuits which are wired incorrectly to achieve the goals described. Explain what needs to be corrected in the space provided, and then draw the correct connections. So let's have a look. I'm going to zoom in here to this first circuit, circuit 1. And the goal, let's see, it says that switch 1 is supposed to control outlet 1. That's this guy here, so that it can be turned on and off. Outlet 2 should always remain on regardless of what is happening with switch 1 or outlet 2. Okay, and so that's the idea. So let's have a look at our circuit here. We've got our power supply up at the top, right? This is the hot side. I'll label that hot. This is the common side. That's common. And we also have ground down here. Now, we want to look at the circuit carefully and see if it's going to do the job, and it's not. There's going to be a problem with this. So the first thing I always like to check is I always like to look at the ground wires, and I like to make sure that those are connected correctly. So we'll have a look at the ground, and I'll just highlight those, right? You can see the ground wires are kind of like going from ground, and they connect to the green screw on each of the devices. So you have to go up here on that one. So there they are. So it looks like the ground wire is connected correctly, okay? So that's something you want to make sure of. All right, let's have a look at the white wires, okay? White is common, that's up here, right? And so the common is the way that electricity can get back to the power company. And we've got commons connected to, right, the common side of each of these outlets. It's kind of hard to see, but that is correct, right? The common side of the outlet is the side that has the wide slot. So that looks pretty good, right? So now let's look at the hot, right, the black. And so the hot comes around, and I'm just tracing over here. And then it comes into our switch. It goes in through this screw right here. That's fine. And that's great. Remember, this is an on-off switch, right? So like the inside of this switch looks something like this. It's like you have something that you can open and close. So I showed it in the open position here, right? That's the switch right here. But when you close it, you allow electricity to flow through, and it comes out the other side. And when it comes out, it should go into a red wire, which is very good. Okay, so we've got electricity which flows out through this red wire, and it goes to the hot side of the outlet. And if you plug something into this outlet, you're going to let electricity flow through and get back to the power company. So see how I'm tracing here? So I'm going to do this again. I'm going to just hover and trace. So electricity follows the hot, it comes through, it goes in through the switch on the top part, and then when you close the switch, it can follow through, comes out here, it goes through a red wire, and then it can go to the device, whatever that is, and it flows through the device and it comes back to the power company. So that's great. So far, everything is really good. Now, there is a problem, and what we want to do is circle the problem in blue ink. So let me get my blue ink ready, and I hope you've already spotted it. The problem is that nothing is connected here, right? And that is a problem because there is no way for electricity to ever get to this outlet. So what you want to think about is like, where is that connection going to come from? Okay, so we're gonna sketch that in the next picture here. Okay, but what we want to do is to describe what's wrong with the first circuit. So what's wrong is that there is no hot connection to outlet 2. Right? It's just missing. Okay. And so what we're going to need is the corrections that we want to do is we're going to have to add a hot wire to the outlet 2. Now we simply want to add a hot wire. We do not want to add a red wire. We do not want outlet 2 to be switchable. We just want it to be on all the time. So this is a pretty easy one. So I'm going to switch over to my black ink. I'm going to sketch it right now. And I'm going to use black ink to just kind of show that black wire coming in here. That's great. But I'm also going to make a little dot here, and I'm going to extend another black wire down, and I'm going to connect it there. Okay, so that's the fix. That's the fix, right? I added another black wire. And that black wire will always be hot all the time. Okay. I'm then going to go ahead and I'm just going to reconnect my red wire here to there. And then I'm going to do my white wires, right? This brings electricity back to the power company. I'm also going to add another white wire down here, and that's okay. I can just cross over and I can make it look like before. Okay, so that's basically the same thing as the first diagram. And then the last thing I want to do is add my green for ground. And of course, you can do this sort of a thing. You can be creative, whatever, but just make sure that the green wires all go to ground. So there you go. Just to review what we did here is we identified the problem that happened in the original circuit. We circled it. That's all you have to do there, okay? And then in the second picture, we added, right, we added the correction, and then we described what was wrong with the original circuit and how we fixed it. So that's pretty simple. So that's really what you're going to do for part one. So you've got a couple circuits to work on there. They're a little bit more complicated, but circuit 2, and then circuit 3 and circuit 4. Okay. Just to preview in the next part after that, for part 2, these are circuits which have the correct functionality. That means they work right, but there's a problem with the colors. And so you'll have to identify which colors are not appropriate for each of these diagrams. So I think you can figure that part out on your own, and then you're going to be putting an answer in here and marking up your diagram. Okay, so find a way to kind of indicate which of those wires is not correct and then correct it. And then the last part here, part 3. All right, this is something that some of you did in activity 3. This is the stairwell or the classroom combination of switches. And that is, you know, if you go in a stairwell, a lot of times there's a light switch at the bottom of the stairs and at the top. And you want the switches to kind of work together so that if you flip either one of the switches, you're going to change whatever the light bulb is doing. Okay. Now this is sort of a tricky switch, set of switches to use, but it's a really, really typical one. Even in this classroom, there may be 3-way switches because we have 2 entrances to the classroom. So you could have, you know, even in schools, these are all over the place. So anyway, this is the picture. Now you're going to draw the circuit wire connections here. Some of you already know what to do if you did this correctly in activity 3, but a lot of you didn't do this. Please notice that these are 3-way switches. Okay, so this is important. So in a 3-way switch, remember that you have something like this on the inside where that comes in, and then it can either go this way or that way to come out. So you have to kind of choose. So these are not on-off switches. I also know that because I usually have 1 black screw and then I have 2 silvers or golds, right? That's what makes a 3-way switch. Of course, this last one is just a ground. And that's different from an on-off switch. An on-off switch just has 2 switches on the side, 2 screws on the side, but nothing, it doesn't have this extra one right here, okay? By the way, this is the bulb. It's kind of a weird symbol for a bulb, but that's what that is. And this will be your power. And so why don't you make, I don't know, why don't you make this the hot side, and this can be the common side. Whatever, just make 1 hot and 1 common. Now, if you've never done this before, here's the thing. You're going to need some help. And I would strongly recommend trying to make this circuit in PhET first before you do anything. So up here, it says before you sketch the connections, test out your ideas in PhET. Now, unfortunately in PhET, there are no 3-way switches, but you can instead make your own by connecting 2 on-off switches in a Y with a short wire segment. So see this figure. So see this? This is a DIY 3-way switch. This is a make your own. Okay, so you've got 2 on-off switches. You see where those come from? And you can put those together and they join up here, and then you add a little wire segment in there. That's a 3-way switch, okay? That switch is actually this thing right here, right? And what you do is you have to always make sure with a switch like this that like one of these is closed and the other one is open, right? That's closed and that's open. So you have to flip back and forth, okay? Or you might decide to make this one closed and this one open. But you always have to close one and open the other. That's very important. Otherwise, you don't have a 3-way switch. So you have to be kind of creative with this, but those are your things. So what you want to do is find out, well, how do I connect these wires, right? Where do I connect that? Where do I connect this? Where do I connect this? And here's my light bulb and here's my battery. And so you've got these 2 switches and you have to put them together. So I would really, really, really recommend building this in PhET and testing it. And once you figure it out in PhET, then you can go back and you can draw the actual connections like they would show up here. And then you sketch it here, okay? So that's a tricky one. Work together, help each other out, but really try to work it out, right, on your own. Think it through. Don't just go to somebody else who got it right and copy their work because you're not going to learn nearly as much. Okay, so hey, that's our activity for today. I would like to have you finish this by the time you leave class today. And then the next time you come to class, right, when I see you next, we're going to actually test faulty circuits using the digital meters. So today is your time to try this on the computer. And the next day is going to be the time to try it with the real world things. So if you don't finish this activity in class for whatever reason today, please do it on your own so that you can come ready to test things out in our next class. So have fun.